Hi everybody, I'm here today to talk to you about powers of 10 and exponents. Now this is the fourth lesson in your math book. The essential question, which can be found up here, is how can you use an exponent to show powers of 10? Ooh-wee, so I think in this lesson we're going to have to figure that out. And I guess part of the problem is we probably don't even know what an exponent is. I'm not sure. Okay, let's take a look at this. Unlock the problem. Now it says here, expressions with repeated factors. So I'm going to mark that part. Repeated factors, such as 10 times 10 times 10. So we see how that's going on and on forever and ever. In this example, there's 3 of those, but you could have more than that. Okay, those are called repeated factors. This goes back to that right there, boys and girls. This is my sloppy looking arrow. It can be written by using a base with an exponent. Now these are the vocabulary words in this lesson. If you have a math book, these words are on flashcards in the vocabulary part of the math book. And you could even cut those words out like index cards and study them like that, or you could just read them, flip them back and forth. Okay, the base, it says, is the number that is used as the repeated factor. So here we have 10. See, 10, base, right there. And then the exponent is the number that tells how many times that base is used as the factor. And that is written as a tiny little number always to the right. The tiny little number always to the right, always to the right. And it's always very small. It floats up there. Okay. Now that means how many of those 10s there are. We see that in that example. And this is always used to show multiplication. That's factors. It's never used to show division or addition or subtraction. And then to find the value of that, we would multiply 10 times 10. Get that answer. That would be 100. And then multiply that times 10. 10 times 10 is 100. 100 times 10 is 1,000. You'll also notice a pattern here with how many zeros I have with that tiny little number. I don't know if I see a pattern yet. We'll have to keep going. Okay? How I would read that number in word form, I would say the third power of 10, or I'm going to write it another way. I could say 10 to the third power. 10 to the third power. That's also acceptable. And this is how I write that. That's called exponent form. Okay? Now, in this lesson, you're using base 10 blocks. If you would like to use base 10 blocks, you can find a virtual set at this website here. Now, if this does not, is not a click and go there link, you can copy it, you can drag over it, highlight it, and paste it into your window, or type it letter for letter. This is at ABC, and this time the base 10 blocks do go all the way up to the thousands cube. They will look just like this, except for they'll be purple, I think. Okay, so now we're going to try to solve this problem. What is 10 times 1,000 written with an exponent? And here I have all the place value blocks, and they're showing how to write them in all these different forms. So let's look at that closely. All right, so I'm going to start with 1. Now this is our unit cube. We write that as 1, 1, or 1. That would be written as 10 to the 0 power. I have no extra zeros. Do we see that? So my tiny number here is 0. Then I have, here's my long, my rod. That's the same as 10 ones. That's 1 times 10, written in expanded value form. That's 10, written with a tiny 1, 10 to the first power. See that? Do we see this, how that's changing? Okay, then here's my 100. That's 100 ones. That's 1 times 10 times 10. How many tens is that? That's 2 tens. 2 tens it takes to make 100. How many zeros are in 100? Let's look. 2. Magic, magic. Not magic, boys and girls. That's a pattern. Let's look again. When I have no zeros, 1 has no zeros, my exponent is 0. 10 has 1 0. I have a tiny number of 1. I have 2 zeros. Guess what? My tiny number behind the 10 is 2. And here I have 1,000 ones. Oh, and look how many tens that is. That is 3 tens. So my tiny number is 3. See that? Okay. So now we'll start filling in these answers. How many ones are in 1? That's 1. How many ones are in 10? How many ones are in 10? 10. Not 19, 10. How many tens are in 100? How many tens are in 100? That's 2. How many hundreds are in 1,000? How many hundreds? Well, I need to think. There are 10 groups of 100, or 10 times 10 times 10. So I have 10. 10. Let's go back here. I don't think that's right. I have 10. 10 tens. Right, because 10 times 10, not 2. Not 2. 10 times 10 makes 100, boys and girls. I don't know what I'm thinking. Okay, next. Move on. How many thousands are in 10,000? How many thousands would there be? That would be, let me think. Probably, I would go with 10. It seems like there's a pattern. All right. And if I wanted to draw a picture of what that might look like, they're telling me to use this shape to represent 1,000. And I want to draw a quick picture to show 10,000. So I need to show that. I'm going to draw that. So how many will I need? Well, there's 1,000, 2,000, 3,000, 4,000. I'm going to need a few more. 5, 6, 7, 8, 9, 10. Okay, now I've just made 10,000. So how many thousands did it take? It took 10. I can see that now in my picture also. And how many tens is that? Let's look. 1, 2, 3, 4. Do we see how the groups of tens is increasing? How many tens? That makes 4. I'm going to come right in here and write a tiny 4. I'm going to use red this time and click in my box and put a 4. I'm going to move that down just a little bit. So that's 10 to the 4th power. Okay, and that would be 10,000, right? So 10 times 1,000 is 10,000. That because this is 1,000, and I've just gone 10 times more than that to make 10,000. So this would also be 10 to the fourth power. Notice that I have in 10,000, I have 4 zeros, and here my exponent and my power of 10 is also a 4. All right, we're going to continue now. Our example here, we're going to, the hummingbirds beat their wings very fast. The smaller the hummingbird is, the faster it beats its wings. The average hummingbird beats its wings about 3 times 10 to the third times a minute. How many times a minute is that written as a whole number? Okay, so we're going to be looking for a pattern. We're going to start with 3 times 10 to the 0. That's the same thing as 3 times 1. That would be 3. 3 times 10 to the first power is the same thing as 3 times 10. That's 30. Oops. That's 30. 3 times 10 to the second power, how many tens is that? That's 2 tens. 3 times 10 is 30. 30 times 10 is 300. Last. I don't know why that keeps happening. That's so frustrating. Okay, so look at what's happening. Do we see a pattern? So now we're up to our final power of 10. We have 3 times 10 to the third. So now we have 3 tens. Our answer is going to increase by 1 more 0. So the average hummingbird beats its wings about 3,000 times every minute. Now let's talk about the pattern that we see. The number of zeros increases by 1 as the power of 10 increases by 1. Okay, my example, 3, 30, 300, 3,000, then 3,000, okay? See how my 0 in my examples, I keep going increasing, increasing, increasing. And I don't think I can write exponents in my my thing here. Okay, maybe. Okay, so now we're going to go ahead and go on. Okay, to the share and show. So now here I have 2 tens multiplied. To do that with Google, Kami, you're going to want to write your 10. Okay, that's your base. And then you're going to want to put another text box somewhere above it to be able to write how many tens you have. There are 2 that are there. Okay, and then you can always drag it and put it in the right spot. It should look kind of like that when you're finished. That's 10. 10 to the second power. Or you could also write the second power, power of 10. Okay, now let's just work on some of these really quickly. Here we have a find the value. So to do that, we're going to want to stretch that back out into its normal form, its more expanded form. So 10 to the second power, that means the same thing as 10 times 10. What is that, 10 times 10? That's 100. Okay, now let's look at number 4. Here, we need to figure out what 10 to the second power is first. That's the same thing as 10 times 10. 10 times 10 is 100. You need to do that simplification first and then multiply on your 4. That answer is 400. Okay. All right.